Okay, now we're going to go ahead and start discussion about Chapter 2. At Chapter 2 we start getting a little more involved in actual algebra, and the first part we're going to be talking about is linear equations and inequalities of one variable. So some of the definitions going to come up is going to be the addition property. We know we heard about properties and stuff in Chapter 1. Chapter 2 we're going to be talking about addition property of equality. The same real number may be added to both sides of an equation without changing the equation solution. So what that means is, if we have something A is equal to B, okay, so pretend A and B are actually the same value. If we add C to both sides, even though we change the way it looks, it still means the same thing, right? It still is the same amount. Imagine this is like a teeter-totter, and on this side we have one person, and they weigh the exact same as this person. Well, if we add 10 pounds to person A, the teeter-totter will still be balanced if we added 10 pounds to person B. So we can change the way it looks, but we can't change the actual equals. As long as it still equals, we're okay. Okay, so that's the main rule. We can change the way so many of these things look as long as it's still equal. And the definition of linear equation, you see we have the form of ax plus b is equal to 0, where a and b are real numbers and a is not equal to 0. So that means we actually have a coefficient with an x in there. Later on we'll learn that the reason they call it linear equation is because these types of equations, ax plus b, when you graph them out, they make lines. The graph of this is a line, and we'll cover that later on. But here's some examples of a linear equation. 4x plus 2 is equal to 6. The variable in this case, we call variable usually the letter or symbol that represents something we don't know we're trying to find. The variable is going to be x here. Some properties of addition of equality. The same real number or algebraic expression may be added to both sides as long as we don't, without changing the value. And the same thing with subtraction. We could subtract something from both sides as long as we do it to both sides. So you see kind of the game we play here in algebra, and this is like the golden rule of algebra. You can do anything you want. You can do absolutely anything you want to algebraic expressions as long as you do it to both sides of that equal sign. Some simple rules to follow when you're solving linear equations. Simplify the algebraic expression on each side. That means combining like terms. We covered that in Chapter 1. We have to combine all like terms. Number 2 is collect all variables on one side and all the numbers or constant terms on the other. We'll kind of demonstrate what that means, but everything with like the variable we want to the left or right, whatever you choose, and everything that's just a constant we want to the other side. So we want to separate all the variable terms with all the non-variable terms. Next we want to isolate the variable and solve, and there's a way we can do that. We'll talk about that, and to check the proposed solution. There's always a way to check this, so especially in quizzes, take advantage of this and make sure and check your work so that you get full credit on your quizzes. So here we have an equation, x minus 9 is equal to 12. So it does take some creativity to try to think of the value that may work here that makes this solution, makes this equation work. And it can be hard, especially later on, to try to think of the numbers or numbers that fit here. So what we try to do is we try not to be creative and just guess. Instead, there's ways we can solve. So the way we solve is we say, okay, we follow our thing, we can simplify this. Well, it can't simplify anymore because the equal sign is already simplified. We have the x terms, the constant terms, and just constant terms on this side. Next we want to go ahead and put all the variable terms on one side and all the constant terms on the other. So we see on the left side we have the minus 9 on the left side. We want to get that minus 9 out of the left side and put it to the right side. Well, the way we do it is we add 9 to this side. And remember the golden rule of algebra, we can do anything we want to one side as long as we do it to the other side, the exact same thing. Since we added 9 to this side, we can add 9 to this side. So we know that minus 9 plus 9 cancels out to equal 0, and x minus 0 is just equal to x, and now we have 12 plus 9, which is equal to 21. So now we have the solution, x is equal to 21. This is a solution because we just have an x all by itself with no other coefficient equal to a constant value. So the way we write this is x equal to 21, and you can put it in brackets. I'm okay with you guys just saying x equal to 21 and circling it. Subtraction is just addition, we know that, of an opposite or an inverse, additive inverse. So if we have an equation x plus 6 is equal to 9, well, we know that we want to get the 6 away from the x and we want to bring it to the other side. Well, the way we get rid of a positive 6 is by adding a negative or subtracting 6. So remember, we can do that as long as we do it to both sides. That's the key thing. We got it to both sides. So if we say x plus 6 minus 6, and this, we know that 6 minus 6 is equal to 0, is equal to 9 minus 6. As long as we do it to both sides, we're okay. And now we know 9 minus 6 is equal to 3. So x is equal to 3, and this is our solution. Now we can go to consider where we have a variable on both sides. Well, it's the exact same thing. It looks a lot different, but it's the exact same thing. We follow the exact same rules. We know we want the variable stuff maybe on the left and all the constants on the right. So we say, okay, let's get how can we get this variable from the right to the left? Well, it's a plus 4x. How can we make that equal to 0 on this side? Well, we subtract 4x. So if we subtract 4x from this side, we know we have to do the exact same thing to the left. So here we go, we see a minus 4x. Now we can simplify this. 5x minus 4x is equal to x. 4x minus 4x is equal to 0. And we've got a plus 3. X is equal to 3 is our answer. Here's just some more examples. We see that we have the x's on the left and a constant on the left and just x on the right. Well, so far we've been taking the x's to the left and the constant to the right. Well, this is a case where we say, hey, we don't want to make too many moves, so let's go ahead and just look at this before we go ahead and work. And if I was to get this x and move it to this side, I'll have all my x's on one side and then all my constants on the other, and I would only have to make one move. So we do that by saying, okay, let's get rid of this 14x. We get rid of the 14x by subtracting 14x, and we can do that as long as we do it to both sides, right? We got to do it to both sides. So now if we subtract 14x from 15x, we end up with just 1x, and we end up with a 2 on the side. So x is equal to 2, or 2 is equal to x, and that's our answer. So now we're going to go one step further and we're going to solve and check. So the first thing, if we have a long problem like this, what we got to do is we have to reduce. Okay, we have to collect like terms. So on the left side, if we collect like terms, we're going to have 5 minus x, because 3x minus 4x is equal to minus x, and that's what we get here. On this side, we're going to have a 1 minus 2x plus 12. Well, here if we collect like terms, we're going to get 13 minus 2x. 13 minus 2x. So we combine like terms, and now what we want to do is we want to go ahead and move the x's to one side and the variables to the other. So to move the variables on the left to one side and the x's to the other, we know that we have let's see, we started with 5 minus x. We want to bring the x's to the left and the constants to the right. So we have a 5 over here minus x plus 2x. The reason we had a plus 2x is because we had a negative 2x over here. We know if we add 2x to both sides, it gets rid of it on the right and adds it to the left. So now we have 5 plus 1x is equal to 13. Now we want to get rid of the constant on the left and bring it to the right. The way we get rid of 5 on the left is by adding or subtracting 5 on both sides. If we do that, we get x is equal to 8. I'm going to stop, running out of time, and I'll continue the lesson in the next video.